Hello everyone, my name is Abhishek and welcome to day 5 of AWS Zero to Hero series. Before we start today's topic, let's quickly recap what we have learned as part of day 4 because day 5 is going to be an extension of day 4 or you can consider it as a part 2 of day 4. So what we have learned as part of day 4 is firstly we understood the concept of VPC, virtual private cloud. We discussed about the different components of VPC. We tried to understand these things with a real life example. We took an example of a secure gated community and tried to relate it with the world of AWS and VPC. After that, what we did is the most important thing, that is we understood how traffic flows within VPC and finally reach the application, right? So let's say this is a user and this is the application. We discussed how multiple components of VPC in the real world, right? So in the world of public private subnet or in the world where organizations use AWS, we discussed how different components of VPC such as internet gateway, load balancer, route tables, how each of them interact with each other and finally send the traffic to the application. So this is what we understood theoretically on day 4. And I explained you on day 4 that VPC is one of the most important services on AWS. Why? Because VPC is the one that introduces the concept of private cloud in the world of public cloud. What is that? I mean to say, VPC is the one that introduces the concept of virtual private cloud in the world of public cloud and adds a lot of security. So without VPC, security on AWS will not be as good as what it is today. So it is important for every DevOps engineer or the one who is learning AWS. Let's say you are just learning AWS. It is important for everyone to understand the concept of virtual private cloud. If you are learning AWS, that means VPC is the one that you need to understand by default. So that's the reason why I told you in day 4 as well, we will do day 5, day 6. That means today's class and also tomorrow's class on understanding the components of VPC in detail, right? As part of that, in today's video, what we will do is it is going to be both theory and practical. And theoretically, practically, we will understand one of the most important concepts of VPC, which adds additional security, that is security groups as well as NACL, right? So this is what we are going to learn in detail today, both theoretically and practically. So please watch the video till the end so that even you can perform this activity, like even you can take this as an assessment and you can try this at your end by watching this entire video. Got it? So now without wasting any time, let's quickly see what is this security group, what is this NACL, and what exactly they are going to do within the VPC. So if we go back to yesterday's video very quickly, what I told you is if you consider this as VPC, right? Let's say this is a virtual private cloud. And I have explained that, okay, in the world of virtual private cloud, the very first thing what you will do, this is a real life example, right? How organizations use VPC as of today. This is the same thing. So initially you will have something called as an internet gateway, right? So usually what happens is within the VPC, there will be a public subnet. So, and there will be private subnet, right? So what is a subnet? Basically, I explained in the last class, when you create VPC, you will define what should be the IP range or what should be the IP address range of your VPC. It is just in the similar terms, you can consider how many IP addresses you want inside this VPC, right? So usually, let's say that when I create a VPC, if I say that the IP range has to be 10.1.0.0-16, then that technically means you will have within the VPC 65536 IP addresses. Okay, so this defines the size of VPC, how big a VPC or how small a VPC. So when you have 65536 VPC IP addresses, that means technically you can use 65536 applications components within this VPC. Okay, so let's not go into the detail of this, but just understand that when you create VPC, then you define an IP address range which defines what should be the size of your VPC. Now within that you can divide subnets. So subnets are basically like within VPC, if you have multiple projects, Okay, so as a DevOps engineer, you have created an AWS account. Then you have created a VPC for one of the project. Within the project also, there will be internal projects, right? So for each internal project, for group of applications, you can define private subnets. Okay, so these private subnets basically will not have access to internet. That's why they are called private subnets. So by default, these applications cannot be accessed from internet. So that's where VPC comes into picture. And what VPC does is, whenever, let's say this is a user. Okay, I know that I'm taking time here, but this is very, very important for everyone to understand. When user eventually want to reach here, like, user want to access an application here, what happens is user firstly tries to go through this internet gateway. Okay, and this is a public subnet where anyone can access this public subnet. Okay, saying that you can add few conditions here through the internet gateway, and through the API gateways you can add conditions and validate few things. Is this user good user, bad user, hacker, or whatever it is? We will talk about that later. So through the internet gateway, initially what happens is, within this public subnet, DevOps engineers usually place a load balancer. Okay, so load balancer can be directly accessed from outside world. And what happens is, this load balancer will talk to this private subnet. Okay, so load balancer is the one that has access to private subnet, and this user has the access to load balancer. And within the load balancer also, you can do a lot of configurations. You can restrict traffic, you can say that, okay, etc, etc, and you can make this more secure with the load balancer as well. But today's topic is about, once the load balancer forwards the request to the private subnet. Okay, so there are two things. One is, you can add additional security at the layer of this subnet. Okay, for each subnet, AWS says that, hey, you can add more security at the subnet level. Okay, so if you add more security at the subnets level, what we will do is, we will start using NACLs. Whereas even if you bypass this, let's say you have not added anything at the subnet level, you can, as a DevOps engineer or the application owner, what you can do is, you can add more security at the EC2 instance level. Okay, the level where your application is actually deployed. So at the EC2 instance level, if you add security, then we call it as security groups. So using security groups, you can add more security at the EC2 instance level. Whereas if you want to add more security here at the subnet level, then we will use NACLs. Okay, don't worry, even if you haven't understood exactly what is happening here, when I deep dive and explain it further, you will understand. But for now, here what I wanted to explain is, in AWS, there are multiple layers where you can add security, because security is one of the key components. For any organization, if they want to move to public cloud, what they will first see is that public cloud secure enough or not? You can talk about costing, you can talk about any level of things, but for any public cloud, tomorrow if there is new public cloud, what you will first see is how secure this public cloud is, because you are going to put all of your application in the public cloud, right? So if your organization is using AWS, it will have your organizational user details, you will have details like the database, and everything is hosted on AWS. So first thing organizations look at is, how secure is AWS? And that's where AWS says that, okay, we will do our part. So the fundamental thing that AWS says is, in AWS, security is a shared responsibility. Understand this sentence very keen. In AWS, security is always a shared responsibility. What does this mean? So AWS says that, okay, from our side, we will try to add as much security as possible. Like, we will tell you that you can use VPC. We will tell you that, hey, you can add security groups, you can add NACLs, you can add API gateway, you can add a lot of security. But along with that, we will need, that means AWS is saying, along with the things that we are adding, we need help of DevOps engineers or AWS admins, whoever it is, like, right? Most of the times, AWS admins are also DevOps engineers these days, or network admins, system admins, whatever your company calls it. But AWS says that security should be a shared responsibility. We will do our part. As DevOps engineers, AWS admins, or network admins, you also have to do your part. And that's exactly where all of these component comes into picture. Whether adding load balancer for your organization, do you want to use default load balancer, different load balancer? Do you want to use API gateway or not? And how exactly you want to configure security groups and NACLs? All of these things DevOps engineer plays a very critical role. In today's topic, we will debug and deep dive into security groups and NACLs, which comes at the last point of security, right? Which comes at the last point of security. But this is very critical because if you are not taking necessary actions at the last point, then your application will be easily hacked, right? NACLs and security groups are very critical because of this very reason, that is they act as a last point of security in your AWS account just before the user request reach the application, right? If this is user and this is where the application is, it has to travel a long path, right? The request has to travel a long path within the VPC. It goes through multiple components, but when it reach here, before this point, the last point of security is served by security groups and NACLs. Okay, so that's why this is very important and we will try to focus. I will explain you like what and when to use security group and what and when to use NACLs. So firstly, let's start with this concept on understanding what is the primary difference between security groups and NACLs. So security group basically serves at the instance level. Okay, now what do I mean by this? On day 3, so whoever has followed our day 3's video, or in general, what we have done on day 3 is firstly we created an AWS account, right? In the AWS account, in the default VPC, like whenever you create AWS account itself, AWS will give a default VPC. Without VPC, AWS will not deal with anything. If you want to create custom VPCs, you can do, as we will do today, but by default, AWS will give you a VPC. And what we have noticed is we created an EC2 instance, and within this EC2 instance, we tried to deploy a Jenkins application. And as a user, we tried to access this Jenkins application. What happened? We were not able to access this application by default because, as I showed you in that video, there was something that was blocking this one, right? So by default, as I told you, in AWS, security is a shared responsibility. And by default, what AWS says is we will not allow anything to your instance directly. Okay, so if you want to do that, you need to configure your security group. Okay, so if we want to configure anything at the instance level, that we do within the security group concept in AWS. And that's exactly where to access the Jenkins application deployed in the EC2 instance, we have allowed port 8080, or you can also allow all traffic. Okay, so this is where DevOps engineers and the application owners have to be very careful. Instead of opening port 8080, let's say in your organization, you have opened some other port. Let's say you have opened port 9000, 10,000 and multiple other ports. And there was one hacker who was trying to access this, and they were luckily able to access these ports and they tried to hack something. Okay, or additionally, whenever you open ports that are not used, or you keep opening a lot of ports, then there can be some kind of unwanted traffic that can flow to your EC2 instance and reach the application. So AWS is doing the part of by default not accepting any traffic, whereas as DevOps engineer, you have to do your part by allowing only specified traffic into your EC2 instance and into your application. That thing is done by security groups concept in AWS. I hope this is clear. If you still feel that this is not clear, when we do the practical, you will understand. We will deploy a Python application and I'll show you this same thing again using the security groups. Now you might ask me, okay, this is a very easy topic. So it is an easy topic, but there are few things to understand in the security group. So within the security group, basically, there are two things. One is there is inbound traffic and there is outbound traffic. What is inbound and what is outbound? Basically, when you deploy your application inside the EC2 instance, right? So if this is an EC2 instance and this is your application, there are two kinds of activities, right? What is the first activity? As a user will try to access your application, and as an application, probably you will try to access google.com, or you will try to access something to get some kind of information, or you want to access some third-party application. So this traffic that is flowing into your application, okay, this is called as inbound traffic. And this traffic which is flowing outside of your application is called as an outbound traffic. For example, let's say this application that we are talking about is Amazon.com. This is just a blunt example. Okay. So user, today I can be a user who will try to access Amazon.com, and Amazon.com probably can access any third-party application, for example, Razorpay, or Amazon.com can access other application like Amazon Pay. To access Amazon Pay, Amazon.com, this request has to move out of this one, right? Go out of your EC2 instance and access some other application, that is Amazon Pay, and user will try to access the application. So this access where user is trying to access Amazon.com is called as inbound traffic, whereas Amazon.com trying to access the Razorpay or the Amazon Pay is called as a outbound traffic. Okay, so as part of security groups, you can manage both inbound traffic and you can manage the outbound traffic. That is traffic coming into your EC2 instance and traffic going out of your EC2 instance. Again, like I told you, you should be very careful, because AWS by default, what it does, okay, by default, when you create a security group, or by default, when you create an EC2 instance, AWS will assign a default security group, because AWS will also take care of your security. Right. So in this default security group, what AWS says is, hey, what I'll do is by default, I will allow all the outbound traffic. Okay. All the outbound traffic I will allow. Like using your application, you can access anything in the internet except for port 25. I will tell you why. There is a story behind this port 25, but except for port 25, I'll allow you all the outbound traffic. And what AWS says is, but anything that is coming inside, okay, anyone who is trying to access your application as inbound traffic, I will deny everything by default. Okay, in the security groups, what AWS is doing is, for the inbound traffic and for the outbound traffic. Okay, for the inbound traffic, what AWS is saying is, okay, I have a lot of restrictions here. I don't want to allow anything. If you want to allow anything, then you can use the concept of security group inbound traffic rules, and you can add the specific port number or the specific IP address where the traffic has to be accepted. But as part of outbound traffic, I'll allow everything. And if you want to restrict, okay, or if you want to do any specific configuration, you can do in the outbound traffic. Okay, so this is the thing related to inbound and outbound traffic. We will see in the practical video how we can use this inbound traffic, outbound traffic. Now talking about the story of port 25. So what happens with port 25 is that, so in this story, AWS does not allow the outbound traffic default on the port 25, because port 25 is basically a mailing service. Okay, so AWS does not want you to AWS does not want any kind of spam activity, or AWS does not want to record the IP address of this EC2 instance, or record the IP address where your application is hosted. So AWS by default blocks the port 25 only outbound traffic. There can be a lot of spamming activities or something like that. Okay, so now let us see if security group is doing all of these things. Now, why I need NACL? First of all, what is NACL? Right? You might have this question, Abhishek, you have been talking about NACL. You keep saying NACL, NACL. What exactly is this NACL? So NACL basically stands for Network Access Control List. Okay, so this is a very complicated name. That's why in the world of AWS, people just call it as NACL. Okay, so NACL, Network Access Control List, basically goes a level beyond. Okay, so security groups is applied at the EC2 instance level, whereas NACL is applied at the subnet level. Okay, NACL is applied at the subnet level. Now with NACL, DevOps engineers can play even critical role, because let's say you gave an EC2 instance for development team 1. And what this development team did is, just to make their process quicker, what they have done is they have deployed a Jenkins application or any other application. They know that they should not allow all the traffic, but to make it easy, what they have done is they just said that, okay, allow all the traffic inside my EC2 instance. Instead, they could have just opened port 8080, but what they have done is they said, okay, accept everything, allow all the traffic to my EC2 instance, and allow from all the IP address in the world. It can be IP address from Turkey, it can be IP address from India, allow everywhere, everything, and I'm fine with it. So the problem is that this particular instance owner, or this particular development group, they have, for some reason, they have ignored the security aspect in the AWS, right? Because security groups are meant to open only specific ports and allow only specific traffic into the EC2 instance. So how and what you can do as DevOps engineers is, instead of, okay, so this is fine. Every instance owner, they can open specific ports, whatever the traffic they would like to. But additionally, what AWS says is, if you go back to the previous diagram where I said this is VPC, and if this is public subnet, this is private subnet, right? Similarly, there will be a lot of private subnets. So what AWS said is, we will give you more access. Instead of instance owner defining what kind of ports or what kind of traffic is allowed, if they do some kind of mistake there, and if they say that allow all kind of traffic, as DevOps engineers or administrators, you will have one more layer where at the subnet level, at each of the subnet level, what you can do is you can define what kind of traffic do you want to deny. Understand this carefully. Here I am saying what kind of traffic do you want to deny. So if you deny some traffic at the subnet layer, even if you try to do that, or even if you try to accept that at the security group layer, there will not be any advantage. So DevOps engineer, network engineers, or AWS administrators, what they can do is they can make advantage of NACLs to define their organizational network traffic. Okay, so if something is applied at the subnet level, then it is by default applied to all the instances within the subnet. Okay, so if there are 50 EC2 instances, sorry, if there are 50 EC2 instances inside this private subnet, let's say you gave this private subnet to development team 3. This is just an example. You gave them to development team 3. And what they have done is they have created 50 EC2 instances inside this private subnet. And for some reason, they said allow all traffic. But because you have applied NACL configuration and you said by default deny all the traffic and allow only specific things, if you say that at the NACL layer, what will happen is AWS will deny all the traffic that is flowing in and only allow the configuration that is defined in the NACL. So NACL will add as an additional layer of security. Got it? So instead of applying the configuration for each and every EC2 instance, also you can use NACL for automation. So maybe in your organization, DevOps engineers are the one who is taking care of the instance level security, that is security groups, as well as NACLs. Then what you can do effectively is, instead of adding security groups for each and every EC2 instance, if you just apply NACL to the subnet, if there are 10,000 EC2 instances also, this NACL configuration is directly applied to all the 10,000 EC2 instances. Okay, so that you can automate this manual activity of assigning the rules to each and every instance using security group. So it is up to you whether you want to use security group, whether you want to use NACL, or you want to use the combination of security group plus NACL. Okay, so NACL, basically the primary purpose is you can deny what kind of traffic that you would want to, and you can allow what kind of traffic you want to. Whereas security groups is only for allowing. Security group does not have deny thing. In security group, you will only configure the rules for allowing. So now we discussed so much here. Probably for some people, there might be some kind of confusion. So what we will do is we will try to deal this same thing practically and make it understandable for people. Practical part that I am going to demonstrate on the AWS account today. So if you watch this carefully, what I'm going to do today is, this dotted lines represents virtual private cloud. So firstly, I'll create a custom virtual private cloud. You haven't seen how to create virtual private cloud, so that's going to be interesting. So firstly, I'll show you how to create this virtual private cloud on AWS. And when you create virtual private cloud, as I told you, security is a shared responsibility. So as I create virtual private cloud and provide the IP address range, AWS by default will create an internet gateway for me. AWS by default will create NACL with default configuration, and AWS will create a route table. Additionally, what I'll do is I will create an EC2 instance and attach a security group to this EC2 instance. Now, once we do this, We will play with this security group configuration and NACL, and we will see how traffic flows into this EC2 application. Sorry, application inside the EC2 instance. What happens if I block something in the security group? What happens if I allow something in NACL and block that thing in, allow something in security group and block that in NACL, right? Allow, block, allow. We will try a lot of things. So let's see how does this configuration go, and you can also try the same thing as your assignment. So because I'll share you all the steps right now, you can watch the video and you can follow the steps as I do. So let's quickly go on to the AWS management console here. So this is the AWS management console, right? So what I'll do now is move to the service called VPC. So this is the VPC service. Some people might be watching this for the first time. They might have not seen VPC before. So what we will do here is, once you go here, you have lot of things within the VPC. Don't get scared. Some of these things you have already learned about in the previous classes. What is VPC? What is subnets, route tables, internet gateway, security groups. Today we learned about NACLs as well. If there are few things that you don't understand, don't be scared. Eventually you will understand all of those things. So click on VPC and let's click on create VPC. Okay, so there is two options here. I mean, there are two options here: VPC only, VPC and more. Go for VPC and more because AWS will take care of creating the resources for you. I mean the default resources for you. For example, when I create this VPC using VPC and more, what AWS is going to do, AWS is going to create public subnet for me as well as private subnet for me in both the availability zones, right? I am in the region North Virginia. In North Virginia, there are two availability zones: US East 1A, US East 1B. So AWS will create 4 subnets, the public subnet and private subnet for me, so that I don't have to create a lot of configuration. In real-time example, like I told you, public private subnet combination is used more. Then AWS is also going to create route tables for me. Finally, it creates internet gateway. IGW stands for internet gateway, and it also creates some VPC endpoints for S3 bucket, which I'll tell you later. Right now, S3 buckets is not taught in this series, so don't worry. Perfect. Now, what I'll do after this is, you can provide any name or you can use the random name. So I can provide some name here for this VPC. Let me call this name as demo VPC. Okay. And this is exactly what I've been talking about. So here, if you see, if I provide this configuration /16, what AWS is saying me that you will get 65,536 IPs. If I want to modify, if I just say this as 1.0/24, see what happened. AWS said that you will get only 256 IP address. So in future, if you require more than 256 IP address, then you have to modify this VPC or you have to add additional configuration. So whenever you create the VPC, if you have an understanding of what is this going to be, what is the size, then that's better. And you can modify these things as well. For example, instead of 10.0.0. Something, you can also change this to 192 series or whatever series that you would like to. So let me just change this to whatever AWS was giving me by default. And now what I'll do is, here you can configure number of availability zones that you want. Technically, I want only one availability zone because this is just a demo thing, but let it be. You can go with the defaults at this point of time because you are just learning. Number of public subnets. I want public subnet because if you go back to the diagram, I am going to do this entire thing using public subnet only. Perfect. All the configuration is provided. Now I can simply, like this VPC endpoint, right now you can put it as none as well, but if you want to go with default, let it be as S3 gateway. Click on create VPC. Now the VPC configuration will be created. See what exactly VPC is doing. Firstly, it created the VPC, then it is configuring the DNS. We will learn about DNS tomorrow. Don't worry. Then VPC creation is done. It has created subnet for me. These are combinations of public and private subnet. Then it created internet gateway. That's why I keep saying security is the shared responsibility. AWS will create configurations for you. Additionally, you have to look at those configurations. You have to modify those configurations if required, add additional security if required. AWS has then created route tables, create route, associate the route tables with the public private subnets, and finally AWS has also done the route table creation. Okay, so this is all the things that are created as part of this VPC workflow. Now let me go back to the VPC that is created for me. And here you can also look at the rough diagram of how does this VPC look like. Just go to the resource map, and here you will get a total picture of how your newly created VPC is looking like. So just spend some time here and try to understand what is happening here. This is exactly what I've taught you on day 4. So you can understand. If you don't understand, you can ask me any specific question as well. Perfect. Now this part is done. I've created the VPC. AWS has created internet gateway for me. See, this is the default internet gateway. In this picture, you can see if you scroll down. So this is the default ingress gateway that AWS has created for me. And AWS also creates NACL and security groups, which you will see. So let me go back and create the EC2 instance now, because I want to place the EC2 instance in the public subnet of the VPC and demonstrate security groups as well as NACL. Go to instances, click on launch instance. What we will do different in today's class from the previous class where we created EC2 instance is, let me call this as demo instance. Let me choose the flavor as Ubuntu. T2 micro is fine for this class, no problem. Provide the key value pair, whatever you would like to use. I'll use this one called AWS login, for example. Here in the network configuration, you have to edit this, right? So edit the network configuration, and in the network configuration, don't go with the default VPC. Default VPC is the one AWS creates for you so that you can start working with it. If someone does not know the concept of VPC, they just entered or they just started with AWS, they can use this default VPC and they can play with it. That's what we did on class 3. On the day 3, we use the default VPC, which comes up with all the default configurations of AWS. But now I want to play with my custom VPC. In your organizations, you will always use the custom VPC only. So demo VPC, let me click on this one and see what subnet is getting allocated to your instance, right? In this case, AWS is saying that I will allocate the private subnet for you, which is a general industry practice. By default, your EC2 instance and the application should be in the private subnet. But because today we are trying to understand this concept and not going in detail load balancer and all the other configurations, so I will change this to the public subnet. How do I do that? Just go back here and change the subnet demo subnet public 1 US East 1. Okay, so because I'm in the availability zone, I want to play with only one availability zone. I've choose the US East 1 availability zone. Assign public IP address. Yes, I need a public IP address for my EC2 instance. Create security group or select any existing security group. Like I told you, if you are not aware of these concepts, then you can ask AWS, to select any existing security groups. But in this tutorial, I'm going to play with the AWS use custom VPC. So let AWS create security group for me, and then let me tweak it. Rest all the configuration looks okay to me. Let me create on launch instance. Now what we will do is inside this AWS EC2 instance that is getting created for me, I will install a Python application. Okay, I will just use a very simple Python application on this EC2 instance. And what I'll do inside this Python application is I'll run the application on port 8000. And now I'll try to access by default. I think most of you already know that when you try to do this, the security group will block, because the default security group that AWS created for you will not allow the traffic directly. You need to allow the traffic explicitly. So I will enable all traffic. I will enable port 8000 and show you what happens. And then we will try to block the traffic. We will say block all traffic in NACL and see what is going to happen. Okay, so this is going to be interesting. Now the EC2 instance is also running. Let's get the IP address of the EC2 instance and log into the EC2 instance using my terminal. So this is my terminal. What I'll do is SSH. I hope I have that PEM key. AWS login PEM. Perfect. Change the IP address also. Great. So let's see. Log into the EC2 instance. And what is the first thing that you do after login to the EC2 instance? You need to update the packages, right? Because I want to run the Python application. So firstly, I want to update the packages. See Python is installed, and then I will run a simple HTTP server. So firstly, do sudo apt update. It will not take much time. All the packages are getting updated. It will not take much time here. Perfect. All the packages are updated now. Now let me see if Python is installed or not. So let me just run Python 3 command. Perfect. Python is also installed. Now I will just run a very simple HTTP server on Python. For that, you don't even have to write a single command, or you don't even have to write a single file. Just say Python 3 -m http.server and provide the port, whatever you would like to. So a simple HTTP server is now running on port 8000. Ideally, if you open this instance on this IP address and access the port 8000, you should be able to access, but let's see what would happen. So we saw the same thing in the last class as well on day 3. There I've used Jenkins, and I tried to access the IP address on port 8000, which failed, and then I enabled, right? So let's try to do the same thing now. This is my instance. Copy the IP address. Just say http colon IP address colon port 8000. The application will not be accessed because what is happening? Let's go and see. This is the EC2 instance. This EC2 instance is attached with a security group. This is the default security group that is attached. And what is happening in this default security group is that, what AWS is saying is I will allow only port 22. This is the port 22 that is only allowed. The reason is also because AWS AWS only wants to allow the SSH traffic. If this is also not allowed, then we will not be able to even log into the EC2 instance. So only SSH is allowed. And let us see what is the NACL configuration as well, right? So if we look at the NACL configuration, just go I'll take a different tab here and open VPC, network ACLs. So what is the network ACL attached to our VPC? This is our VPC, right? Demo VPC. So let's go to that specific thing and see what are the inbound rules. Why are we looking at inbound rules? Because inbound rules is the one that is coming to our application. So it says all the traffic is currently allowed. So network ACL, which is the first layer of defense, okay, which is the first layer of defense for the entire subnet. What is configured here? It said that, okay, allow all the traffic. I don't have any problem. You can say that there is also deny rule here, but deny rule will only be triggered if this condition is not met. Okay, so order goes with the order of priority. Whatever is here in the first row, so it depends upon the number. So least number will be here first. Let's say I'll configure one more rule and the rule number is 200. So first rule 100 will be verified. Then rule 200 will be verified. And finally it will go to rule star. Okay, star is the last thing. Here this condition is met, right? If this condition meets, that is if all the traffic is allowed, then there is no problem. Okay, let's say here instead of all traffic, I can also say only allow custom TCP traffic of port 8000. Or I can say allow only custom TCP traffic of port 9000, which we will see. But for now, all traffic is enabled. So no problem from NACL. What AWS did here is from the internet gateway, you got entry into the subnet. Okay, because NACL is allowing all the traffic, so internet gateway can forward the request to the route table. If there is a load balancer here, then the request would have gone to the load balancer. From the route table, request goes to the load balancer. But because there is no load balancer here, from internet gateway, if NACL accepts, then the traffic goes to the route table, right? So let me add an arrow here so that it is much clear. So this is what has happened here. From the NACL, now traffic goes directly to the route table, and route table would forward the request to the EC2 instance. Let's see what is happening and why if NACL is accepting, why the request is not going to the EC2 instance? That is because security group is blocking it. First layer of defense is cleared, but the second layer or the last layer of the defense, which is security group, is blocking the request. Now let's try to unblock it. So for that, go to the security group, edit the inbound configuration, add one more rule, and inside this say allow port 8000. So custom TCP means the custom port 8000 of TCP. You are allowing port 8000 from any IP address. For now, you can say any IP address anywhere in the world. The resource that is using IPv4 anywhere in the world. Just save the rules, and as soon as it is saved, you will see that the configuration will be applied to EC2 instance. And if I just refresh this page, you will see the output. What is this output? Basically, I'm just running a simple HTTP server, right? I'm not running anything more than that. This is a very simple HTTP server. So that's why what is happening here is the request that you have sent is listing out the directories that are available in that folder. Anyways, you got the request output. You can verify or validate this request output here as well. So you got 200 response. That means the request is successfully sent and you have got the response back. Now, what if, okay, what if you have opened this port, right? So where is this? In the security inbound rules, you have opened this port. Let's say you are the instance owner, you are not the DevOps engineer. And as part of the instance ownership, what you have done is you have enabled port 8000, but your organization has a very strict rule that the port 8000 should not be enabled. So as DevOps engineer, you can configure this, you can control this thing at the NACL level itself. Because you cannot monitor each and every EC2 instance and you cannot control every EC2 instance, you can say that for my organization or for this particular VPC, I will block port 8000 in the NACL, right? Or the network ACL configuration. See then what would happen. So the power of DevOps engineer using NACLs. This is security group. Where is NACL? Let's go to the NACL. Yep. This is NACL. This is the inbound rule. What I will do is edit inbound rules. Instead of allowing all traffic, just remove this, add new rule. And what you will say is in this specific rule, let me call this rule as 100. Custom TCP, port range 8000. I want to block. Anything that is coming from internet, just deny. Now let's save this change. Okay. And let's try to copy this URL, take in a different browser, and just try to enter it and see. Now you will see that the request will not reach the application. That is because DevOps engineering team has blocked that specific IP range, or DevOps engineer has denied that particular traffic in the NACL. So it will be blocked for the entire subnet. Whether you are EC2 instance owner, whether you can be anything, because the network configuration is blocked, you cannot access. Now again, let's try to edit this inbound traffic rule and say that for 100, I will just say all traffic allow, save changes, edit inbound rule. I will add one more inbound rule. Okay. And that inbound rule number is 200. Okay. Custom TCP, port 8000. Any guesses on what would happen? I will deny this. Let's see how much you have understood here. I have added this rule number as 200 and I have denied the traffic. Let's see if I save changes and refresh this, you will see that the traffic is sent. Even you have denied the configuration in the NACL because NACL goes in this specific order, right? So the order would be first, you will verify AWS will verify the first lowest number. The lowest number is 100, or it goes with the specific order that is mentioned here. It is mentioned in the ascending order itself. So firstly, it will check rule number 100, which says all traffic is allowed. So this rule is met. AWS will forward the request. The request goes to security group. In the security group also, you have allowed that port 8000. So it directly reaches the specific application. What happens if I simply rename this one. Like if I make this as 200 and if I make this as 100, save changes. Now, okay, so let's save one by one. So let's keep this as 200. Let's keep this as 110. Okay, you can keep any number. It just has to be the order. That's it. Now try to save the changes. So it will reflect and 110 goes above now. So this is the first rule. What it says is if the port number is 8000, block. If the port number is not 8000, then it will go to the next rule. What does the next rule say? Allow all the traffic. Now let us see what would happen. Just copy this URL, take this in a different tab and try to refresh. Again, the traffic will not reach the EC2 instance. The thing is, now the application developer will be confused. Hey, what happened? I have allowed the port 8000 here, but still my application is not getting the traffic because DevOps engineer or the network engineers have blocked this specific port. Now this port they might have blocked because there might be some security reasons, there might be some concerns. It's not just about the port, but with the NACLs, you can play around with different things. You can play around with the IP addresses. Let's say you are worried about some IP address that is coming from XYZ country. And you know the IP address range, you can say block the IP address that is coming from 3.4.5.6 range. Or if you know the specific IP address, you can provide the specific IP address. If you know this, if you don't know the specific IP address, you can provide the range as well. 3.4.0.0/16, right? You can say anything. You can block on the IP address. You can block on the port range. You can play around with NACL and security group configuration. So what you have understood at the end, even if you allow the configuration in the security groups, NACL acts as the first layer of defense, and DevOps engineers as well as system engineers, network configurations, or the admins who has access to NACLs, they can overall block the configuration at the subnet level, right? So today we understood the topic of NACL and security groups with respect to allowing the access and blocking the access. Please take this as an assessment. You can watch this practical part one more time and you can try this at your end. This is really, really important. Today we just tried with one public subnet. In future, we will enhance the scope. We will add the private subnets. We will add load balancers. We will add API gateways. We'll add a lot of configuration, multiple availability zones. So this concept you will understand even more in detailed way when we play with other components of AWS. But for that, today you have to practice this and let me know in the comment section. Were you able to try the assessment? Were you able to solve this? Do you have any questions? Please let me know in the comment section and I'll more than happy to reply to it. Thank you so much for watching today's video. I hope you found this informative. Please share this video with your friends or colleagues who are looking to learn AWS. See you all in the next video. Take care. Bye.